So we're going to study a little bit more about a series. We talked about sequences and series yesterday. Today we're going to talk about specific series, arithmetic series. And we're going to talk about the really elegant way to write a series. And it's called summation notation, also sometimes called sigma notation. Sigma is just a Greek letter. And when we see sigma, it tells us that we need to add. Okay? So our instructional objective, you will be successful when you can evaluate an arithmetic series using summation notation, and you can do it by hand, and you can do it on your calculator. Okay? So we'll be doing some small sums by hand, and then some really large sums with the calculator because I don't feel like torturing you. So here we go. We're going to start off with the definition of summation notation, also known as sigma notation. And basically, it's a sophisticated way to find an arithmetic series. And more, it's just a sophisticated way to write it. So it's a finite series. It won't be an infinite series. When you get to calculus, you'll attack those kinds of problems. Right now, we're just going to work with introducing this to you because I think for a majority of you, you've never seen this before. We'll keep it really basic today. We won't use it again until the end of pre-calc. But you might see it on like your standardized tests. So I want to make sure you have some experience with it and some exposure. Okay, so what I'm going to do is I'm going to show you the clunky version or the elementary version, the version we worked on yesterday. And then I'm going to show you how summation notation cleans it up, makes it really simple and elegant. So here's a clunky version. It'll say something like, find the sum of the first 10 terms for the rule n. A really elementary way to approach a finite summation or a finite series. So when we translate that, we know that that means 1 plus 2 plus 3 plus to infinity, but we're going to interrupt infinity, plus 9 plus 10. So that's what we were being asked to do yesterday. And this is, of course, a really basic example. And if you remember, there was a shortcut that I taught you for adding these terms. You add the outside terms, 1 plus 10, which is 11, and then you figure out how many pairs can I make out of 10 numbers. 5 pairs, right? So that's 5 times that you're going to get 11. So 5 times 11 is 55. And so you remember that I taught you to add that up yesterday. We'll practice that a little bit more today. So that's the very elementary or the clunky version of a summation or an arithmetic series. The more elegant version looks like this. Sigma, which says the summation of the index starting at 1 and stopping at 10 for the argument n. These two statements say the same thing. Now, of course, if you don't understand what this means, it doesn't matter how elegant it is, correct? But these things mean the same thing. So want to just break up a summation notation into its parts, and we'll define those parts. So these two things, just real quick, they're the same thing. The answer to this is 55. They are the same, okay? But let's just define the parts of the sigma notation or summation notation. When you see the sigma, it's just a Greek letter. Okay, alpha, beta, theta, gamma, all those letters. This is summation, sigma. It means that you're adding a series of numbers. You're adding. Okay, so that means to add. The number on the bottom and the number on the top, I'm just going to use n equals 1 on the bottom and k on the top. These numbers are your indices or indexes. Either one is a proper plural for index. Okay, so your bottom index is your lowest index, and it's your starting index. So you're going to plug in a 1, and then you'll plug in a 2, and then you'll plug in a 3, and then you'll plug in a 4 until you get to whatever k equals. Maybe it's 5, maybe it's 10, maybe it's 100. This one up here is your stopping index. So you stop at that number that you plug in. Okay? And then over here, you might have some value that looks like, say we have n plus some constant, I don't know, I'll just put one in here for example, n plus 2. And typically we call that the rule, but when we're talking in elegant terms, in summation notation, it's called the argument. So you have the summation of index starting to index stopping for the argument. Got it? The summation for index starting to index stopping for the argument. So let's put it into practice, okay, and start to learn how to read this on our own. So we're going to start off with the summation for the index starting at 1, stopping at 4 for the argument n squared minus 1. Are you ready? Well, we're going to do this by hand because this only has 4 terms. Start at 1, then 2, then 3, then 4, then stop. Here's what it looks like. One squared minus 1. And it's a summation, so plus, it's a series. 2 squared minus 1 plus, tell me what you think. 3 squared minus 1 plus 4 squared minus 1. Stop. 4 terms. Term 1 plus term 2 plus term 3 plus term 4. So we'll evaluate this by hand because it won't take long, right? We get 1 squared minus 1 is 0, plus 4 minus 1 is 3, plus 9 minus 1 is 8, plus 16 minus 1 is 15, and then we add 26. So this very simple answer for this very elegant looking, complicated looking summation series, not too bad, right? Bottom number is your starting value in the rule. Top number is your stopping value in the rule. So let's see if you've caught on to what I've explained. You try that one. So if you did that correctly, you should have got the answer 62. I'm going to repeat some things. By starting with plugging 3 into the argument, and then 4 into the argument, then 5 into the argument, and stopping with 6. Okay? So there you have examples that are very similar, but different starting positions. All right. Let's talk now about the product, or the summation of a constant. The summation of a constant, we got a little rule here that you can write down. I've already got it up here. Says this. The summation of a product says this: if C is a constant, you're writing it down? If C is a constant, then the summation of K equals 1 to N for the argument C is equal to N times C, which probably doesn't make a lot of sense in its abstract definition. But we're going to put it in practice so that we can explore this definition and put it into good practice here. I think that the main thing that we should point out here is this rule works if this is 1. It has to start at 1 for this rule to work. And if this number over here is a constant, then you just multiply your stopping value times your argument. So your stopping index times your argument should short the process. So here's what I mean. Here we have our argument is a constant. Do you see what I'm saying? It's a constant. There's no variable there. So we look at our starting position and it's 1, right? And it stops at 5. So how many terms should be in my series if I start at 1 and I stop at 5? 5, right? So if I were to just take this out longhand and not use my rule, that means that I would go position 1 is 13, plus position 2 is 13, plus position 3, plus position 4, plus position 5, stop. But that's just a repeated addition, right? And what's a shorter version of repeated addition? Multiplication. So we go 5 times 13, which is what I was trying to explain to you there. You're just multiplying your top index times your constant, and you get the answer 65. Now, if you truly understand what I'm saying, I think that you could generate a hypothesis that could help you use the same idea to solve this next problem, where your argument is the constant 9, but your starting point is 3, and your stopping point is 7. And I'm wondering if you can come up with some kind of hypothesis to help you determine the answer quickly. And you might have to write it out to check your hypothesis, but go ahead and give it a shot. Okay, so I'm going to pause. So we know that we have to start with position 3, and position 3 is 9, plus position 4, plus position 5, plus position 6, plus position 7, stop. So that's 9 times 5, which is 45. And of course you can do it by hand, just like that. It's not a very big series. It's a really short, finite series. And as I said in the pause, because there's 2 missing from the bottom, then take 2 off the top. You could change this to 1. You could change that to 5. And just subtract 2 from both. And that would take it back down to that. See what I'm saying? All right. So there you have doing the math by hand. On the back of your paper, I would like to discuss how to find things with your calculator. So like if I were to ask you to do a summation of a finite series of 100 terms, I would be really mean if I made you do that by hand. And I would like you to know how to use your technology. So in Desmos, we're going to start there. You know what? I'm just going to go ahead and do this with you. In Desmos, I'm going to teach you in Desmos first. A couple reasons for that. In Desmos, you have Desmos Access at home, right? You can even download it on your phone for free. Desmos Graphing Calculator. And then on your Arizona Merit Test, the Desmos calculator is attached to these types of problems. So I want you to know how to access it. Where do you find it? And how do you type it in? So in Desmos, we are going to go to the function key. And then we're going to go to the miscellaneous tab. And then you're going to choose Sigma. your summation. That's all you, and then you type it in. It's all you have to do. So let me pull up, that's not what I wanted. Woo, okay. So let's say we were going to do a really complicated summation. I'm gonna move my screen over a little bit. Maybe. Oh, nope, I need it over here. Okay, so if I wanted to type in, we'll just do one with a big. So I'm going to come over here to the function key, tap it. In miscellaneous, you got these 3 tabs. The miscellaneous tab down at the bottom, there's your summation, and it'll type it in. And you can change the variable to whichever you want, or whatever the problem says, whatever the variable is, you can just change those variables to n's. You can change them out, doesn't matter. So let's say we started with n equals 1, and we were going to n equals 200. So I want a series of 200. It's a finite series, but it's a big series. And we'll do the argument for 2n minus 3, not 34. All you have to do is type it in. The calculator will provide the answer, 39,600. And you'll be really grateful that you didn't have to do that with some crazy formula that you'll learn in calculus or by hand, because that'd be really mean. And what a waste of your time. Okay, so that's how you do it in Desmos. Be helpful for finishing your assignment tonight. And then I'm going to give you instructions now on how to do this with your TI-84, because when you're in class, you know I'm not going to let you use your phone. It's not going to happen. So I'm going to have you use our tools here. So for our TI-84 plus, and the CE or just the plus, it doesn't matter. You can push math 0. And it will give you your summation notation. Math 0. Quick, right? Beautiful. Now, let's say I wanted you to type in the summation of, in the calculator, I always like to use X because it's a really easy button to find. You don't have to go alpha and find X. You can just push the X button, which is right next to the alpha button. So let's do X equals 5, and then arrow up, and we'll put in 102 for the rule 10 minus X. Type that in. 4,063. Look at that. Okay. So today you have an assignment. I had originally planned to assign the back of yesterday's worksheet, but I decided it went into way too much detail for what we need this year. So I made it a new worksheet. So you pick that up on your way in. 1 through 10, I'd like to see you do by hand. Challenge number 5, to do it by hand, extra stamp on your hot card. For number 5, if you choose to use the calculator, no extra stamp. Okay? So 1 through 10 by hand, and 11 through 14, not 14, 11 through 20 with your calculator because they're larger sums. Okay? And then at the end of the period, 10 minutes before the bell, I'm giving you a mini quiz where you're going to have to do 1 by hand and 1 with the calculator to prove to me that you learned today's lesson.